Hello everyone, welcome to Eduxcite classes. My name is Monit and in today's session we will solve A.1.5 projectile motion. Okay, so this is my WhatsApp QR code. If you want to chat, if you have any doubt, or if you want to continue with some one-to-one personal doubt session or conceptual session, you can just scan the QR code and you can contact me, and the details are also given in the description. Please share this video. That is the only purpose of making these video, and this is my website where you can find out the PDF of this worksheet as well as the marking scheme, whatever I will annotate in this particular video. Okay, so let us start with the very first question. Pause it and solve. Okay, so in the first part, the maximum height, let us say this is the maximum height, and the first and the foremost thing you have to remember for the maximum height is that at maximum height the vertical velocity will be 0. So always remember, this is one of the most common and the popular questions from projectile. So first and the foremost is we have to do the component of the vertical as well as horizontal. So if you remember, if this is u and it's making an angle theta, so the horizontal component will be u cos theta and the vertical component will be u sin theta. I hope you know this. So this will be 18 cos of 52, which I will write ux, and this will be 18 sin 52, which will be uy. Okay, now here you have to specify the direction. So I am taking the upward direction as positive, so downward direction will be negative. Okay, now for the A part, for maximum height, I can say for maximum height Vy, or you can say the velocity will be 0. Acceleration is, I am taking 9.8 in the downward direction, so it will be negative. So we can use v square equals to u square plus 2as. That is the only equation given in your data booklet. We cannot directly use the formula. Make sure you have to derive first and then put up the values. So I will using for the vertical component, so I will use all the vertical components. So Vy is 0, Uy is 18 sin 52 square plus 2 minus of 9.8 into S. S is, we have to find out, which I have assumed as h. So using this you can find out the value of h using your data calculator. Okay, so using GDC you can find out the value of h. I have already done the calculation. So it will be 10.3 meter above the incident point and above the projected point. So the total distance from the ground, total height from ground will be 10.3 plus 1.6, which is 11.9 meters, right? Yes. So this will be your answer for the A part. Okay. Okay. Now for B, we can say to find out the vertical component when it hits the ground. Okay. When it hits the ground, that is what we have to find out. We can use v square equals to u square plus 2as again. Now here it will be vy square. Now if you look at the displacement, the net displacement is, the initial position is this and the final position is this. It is hitting with this part. Okay, so the displacement is 1.6 meter and it is in the downward direction. So I will use uy as the initial 18 sin 52 square plus 2 minus of 9.8 minus of 1.6. So if you put up the values, you will get Vy something around I have already done the calculation. It will be 15.27, so you can say 15.3 meter per second in the downward direction. I hope it is quite clear. Now for C, you can, to find out the time taken, we can use V equals to U plus AT. We know the final velocity in the vertical initial velocity and the acceleration. So it is in the downward, so I will use minus 15.3. This is 18 sine 52. This will be positive plus minus of 9.8 into time. So using this, you will get the time something around 3 seconds. So time will be 3 seconds. Okay. Now the horizontal distance to the point where it hits the ground. Now always remember, for the horizontal distance we can use the range formula, which is, in horizontal distance we always use the horizontal component ux times total time taken for the flight. So that you can say 18 cos 52 times 3 seconds, which will give you the answer something around 33.3 meter. So that will be your answer for the D part. Okay, I hope it is quite clear. Now the velocity of the impact, this is very important, and majority of the students are confused how to find out the velocity. Now whenever they ask us the velocity, you have to specify the magnitude as well as the direction, otherwise you will lose your mark. Okay, so the velocity for the impact at this point, it will be again Vy and U. So the component ux is not changing throughout the projectile, it remains the same. I hope you know this. So the velocity, let me add page here. Yeah, so what I can say, the velocity, the impact velocity, let us assume it as v. So this v square will be equals to ux square plus vy square. So ux is 18 cos 52 square plus vy we have already found in B part, which is 15.3 square is equals to v square. So when you solve for v, I have already done the calculation, it is something around 18.9 meter per second. Now this is only the magnitude. Now if you look at the diagram, it is hitting like this, right? So I can say this will be v, now this will be vy, and this is your ux. Okay, so I can find out this theta. So this theta, if you look, this will make a right angle triangle, right? This will make a right angle triangle. So I can write tan theta as vy over ux. So vy is 15.3 over ux 18 cos 52. So theta will be tan inverse of this 15.3 upon 18 cos 52. So this theta will give you the answer with respect to the horizontal, which is coming as 54 degree. So you can use your calculator. So this will be with horizontal. So this you have to mention. So this is very important to find out the impact velocity when it hits the ground. So the guys, this is one of the most common question, and it covers almost all the parts of the projectile motion. So if you get the right answer, it means you have understood the projectile motion, the basic projectile motion, how to solve the questions, okay, using the equation of motion. If you have any doubt, just comment below. I will try my level best to clear it. Okay, now moving on to the next question, just pause it and solve. Okay, now in this question, In almost all projectile motion, we have to find out the horizontal and the vertical component, without which we cannot solve. But specifically why I have taken this question is because the theta is not given you directly, but you have to use your simple trigonometry concept to find out the value of theta. So first of all, I will find out the theta. So I can say tan theta is equals to 0.84 divided by 2. So if you find out the theta comes out to be something around 22.78 degrees. So this theta and this theta will be the same, and this is the projectile velocity of 3.8. So I can say the horizontal, the A part is the ux is my horizontal component, which will be 3.8 cos of 22.78, and which will give me answer something around 3.5 meter per second. So this will be my first part, and uy will be 3.8 sine 22.78, which will be something around 1.5 meter per second. So you can check using your calculator, you will get the same answer. So these are your horizontal and the vertical component. This was my A part. Now B part says that how far from the base it will go, like this, right? This will be like this. So how far from the base of the plant does the water hit the ground? So for that, first of all, I know the horizontal component, but I need to find out the time. But for time, I have to calculate. For time, first I have to calculate using Sy equals to uy t plus half ay into t square. That is in the vertical direction. So taking downward here as positive, because all are in the downward direction. So 0.84 equals to uy is 1.5 into t plus half of minus 9.8 times of t square. Now using this quadratic equation, if you solve for t, you will get the answer as 0.29 second. I have already done the calculation. Okay, and also if you have not understood how to solve for taking the directions, please watch my previous video. The link for the playlist of A.1 Kinematics is given in the description. So if you have not watched that video, please watch that video. I have explained in detail about how to take the direction for the positive and the negative, and how to use the equations of motion in different directions. Okay, so we find out the time, but now for the range, I can say range will be equals to ux times t, right? So ux times t will be 3.5 times 0.29. So the range, or you can say how far from the base of the plant does the water hit the ground, I can say it will be something around 1.01 meter or 1 meter. So the total distance is 2 meter. So it will hit in between the plant and where it was being projected. So it is same whether you minus it or not. So the answer will remain 1 meter. Okay. So if the answer was less or other than 1 meter, so we have to subtract it from the, so for example, it hits here. So this was the, let us say it comes out to be 50 centimeter, let us say. So if this is 50 centimeter, the answer should be 2 minus 50 centimeter. That will be 1.5 meter from the base of the plant, like this. But here the answer is almost 1 meter. Okay. Now solve the question 3. Okay. Now for the A part, again first and the foremost is this is 13 meter per second, right? So you can say ux will be 13 cos 35, and this will be 13 sine 35. Okay. Now calculate the time taken for the stone to travel horizontal distance to the wall. Now this is the horizontal distance, 12 meter. It is away from 12 meter from where the stone has been thrown. Okay. So I can say time taken will be nothing but um, speed equals to distance over time, so time will be distance, so distance is 12 and the speed in the horizontal direction remains same, which is 13 cos 35. So if you solve for this, something around, you will get 1.1269, so you can say 1.1 second is the answer. Okay, now for the B part, if you look, show that the stone will hit the wall. Now in this case, if I want to show whether it will hit the wall, I can find out where it hit the wall and I can compare it with the height of the wall. If the answer is greater than the height of the wall, it will pass the wall, or if the answer is less than the height of the wall, it means it will hit the wall. Okay, so I will just calculate how at 12 meter what will be the displacement. Accordingly I can compare. Okay, so for that what I can do is, we can use s equals to ut plus half a t square in the vertical direction, right? So here I am taking again the upward direction as positive, downward will be negative. So as I have to find out, so uy is 13 sine 35 in the upward direction. Now for the time I have already calculated in the above part, don't take the round off value, it will add up to your errors. So take the whole complete value of what we get in the above part, don't round off here. So this will be the ut plus half minus of 9.8 times 1.1269 whole square. So if you solve for this, I have already done the calculation, you will get 2.2 meter. So this is from this point, so it means to say that from here it will be 2.2 and it is already 2 meter above. So the whole distance I got, so it hit the wall at 2.2 plus 2.2, that is equals to 4.2 meter above the ground, right? So it shows that it hits the wall, hence you can say hence it hits the wall. Okay, now deduce whether the stone reaches its maximum height before or after hitting the wall. Now before and after hitting the wall, what you can do is, either you can find out using the time at which it reaches the maximum height, or what you can do is you can find out the velocity. If it is in negative, it means it is returning back, right? So I can use v equals to u plus at, vy equals to uy plus at. Time I will take the one which we calculated, so uy is 13 sine 35, right, plus minus of 9.8 into 1.1269. So if you calculate this, you will get your answer in negative, right? So the negative answer is something around minus of 3.6 meter per second. So the negative shows that the object, or what is it, the stone, right? So shows that the stone is moving downwards, which suggests it has already reaches maximum height. Okay, or you can compare the times. Calculate the speed with which. Now be very careful, it is mentioning about speed. So when the question says about speed, no need to calculate the direction, no need to find out the angle, because they just want the magnitude. But instead of speed, if it is written as velocity, then you have to give the direction. So calculate the speed with which the stone hits the wall. So again you can find out, let us say v square, ux will remain same, which is 13 cos 35 square plus 3.6 we have already calculated when it hits the wall, vertical velocity. So if you solve for this, you will get v as something around 11 meter per second. So that will be your answer for D part simply. Okay. So I hope it is quite clear. If you have any problem, just let me know. Now just pause the video for question number 4. Okay. Now in this part, it is mentioned it reaches the maximum height at 0.9 second. Okay. And its horizontal displacement is 16 meter at that particular moment. So first of all, we have to find out the vertical component of the initial velocity. Now I can say at this point, the vertical velocity will be 0, right? And assuming this as u sine theta and this as theta and this as u cos theta. Okay. So I can say u sine theta, I am using v equals to u plus at. So vy equals to uy plus g into t. So upward I have taken positive, downward I have taken negative. Okay. So at this it will be 0. So this will be u sine theta minus of plus of minus g into t. T is already given 0.9. So u sine theta, I can find out the vertical component will be g times t. So that will be something around, if you calculate, 8.82 second or 8.8 meter per second is the answer. So this will be your vertical component. Okay. Now they are asking us the initial speed. They are asking us to find out u, and also it is mentioned that the horizontal displacement is 16. So I say 16 is equals to u cos t, speed into time, which is 0.9. So u cos theta is 16 over 0.9, which is 17.78. I have already done the calculation, right? Now I know u sine theta, I know u cos theta. I can find out the theta. So dividing equation 1 by equation 2, dividing equation 1 and 2, so you get tan theta. So tan theta you will get 8.82 over 17.78. So theta you will get something around 26.38, or you can say 26 degree, right? So this is the answer for the C part, by the way. Then you can do the B part. Using this theta, I can find out, now you can B and C, you can say I am doing together, right? So yeah, so u sine of 26.38 is 8.82. So u will be 8.82 over sine of 26.38, which will give you something around, I have already done the calculation. What's the answer I have done? Yeah, it will be something around 20 meter per second. Yes. So this is your answer for the C part. This is your answer for the B part. Okay. Do not get confused. Now its maximum height. So maximum height we can find out again using, we know the at maximum height, again the velocity component Vy will be 0, Uy is u sine theta, which is 8.82 meter per second, and time we don't know, so I'm using v square equals to u square plus 2as, right? So this will be 0, this will be 8.82 square plus 2 minus of 9.8 into h. So if you solve for this, you will get h as something around 4 meter. That's the answer for your D part. Okay, I hope it is quite clear. If you have any doubt, just let me know. You can download the worksheet. The link is given in the description. Now please try question number 5. Pause the video and solve. Okay. Now you can see that the Olaf is throwing a dart and the net displacement is 0.25 meter in the downward direction. Okay. So here again I am using the upward as positive, downward as negative. Now I have to show that the time of flight of the dart is approximately 0.3 second. So directly I can use for the A part as y equals to uyt plus half ayt square, right? The net displacement in the downward direction is z minus of 0.25. Uy you can find out, the initial speed is given to us as 9, so this will be 9 cos 4 and here it will be 9 sine 4, right? So it will be 9 sine 4 times t plus half of minus 9.8 times of t square. Now if you solve for this t, you will get something answer as 2.99, which is nothing but 0.299, which is 0.3 second. Okay. Now the B part, the distance between the Olaf and the dartboard. So this distance we have to find out what is the distance. So if I find out the total time, I can use the horizontal distance will be nothing but ux times total time t. So ux is 9 cos 4 times 0.299. So this distance will be nothing but 2.7 meter. Okay. You can use the calculator, you can easily find out the answer. Now for the C part, this is B first part and now B second part. Speed of the dart when it hits the bull eye. Again it is asking us the speed. So what we can do is the horizontal component remains the same. So first we have to find out Vy, which is uy plus at. Now this is uy is 9 sine 4 minus of 9.8 into 0.299. So this Vy will be something around 2.31219, right? So this is your Vy, and this will be negative because it is in the downward direction. So don't worry, the downward negative shows it is moving in downward direction, so don't worry about the negative sign. So here you can say the speed, this is the speed at which it hits the dart. Okay, so V square will be 9 cos 4 square plus minus of 2.31219 square. So if you solve for V, you will get the answer as 9.27, which is 9.3 meter per second. So I hope it is quite clear for the B second part. Let me add a new page. Now the C part. Sketch a graph to show the variation with time of the horizontal velocity and vertical velocity. Now we have to just sketch. So if I want to sketch, I can say, if this is, let us say, for horizontal, okay, so horizontal velocity is constant, it is not changing, so I can say, and that is equals to 9 cos 4, which is something around 8.98. So let us say this is V or ux, this is time t. So I am making, let us say, 8.98. It is not changing with respect to time. So 8.98. Whereas if I want to make for velocity in vertical direction with respect to time, then always remember, first it is moving in the upward direction and it is decreasing, but it is positive. When it is moving in the downward direction, it is increasing but in negative direction. So and there will be a time when it will become 0. Okay, so what I can do is I can start from the initial, which is the value is how much, 97 sine 4. So 9 sine 4 is 0.63. So let us say this is 0.63, which is nothing but 9 sine 4, and it will move like this. It will become 0 at the maximum, and it will increase in the negative direction. So and this will be 0.3 because the total time period of the complete projectile is 0.3, and this maximum will be, we have already calculated, 2.31. so this will be the value for sketch for your vertical velocity with respect to time. So if you have any doubt for the horizontal or the vertical component, just let me know. It will be a straight line because the acceleration is constant due to gravity. Okay, 9.8. Now try question number 6. Pause the video and solve. Okay, you should never give up, boys and girls. Okay, so question number 6, A part, calculate the time it takes the tennis ball to reach the net. So always remember, whenever the horizontal displacement is given, always use speed equals to distance over time, because the horizontal component acceleration is 0. So A part, I can say the time will be equals to distance is 11.9 over, I'm using the speed equals to distance over time. So time will be distance over speed, and speed is ux. So 11.9 over, so this is 64. So this will be 64 cos 7, and it will be 64 sine 7. Here I am taking the downward as positive, upward as negative, because almost all vector values are in downward direction. So this will be 64 cos of 7. So if you solve for this, you will get 11.9 second. So this will be your answer for the first A part. Sorry, this will be 11.9 is already given. This will be 0.19 second, 187. So rounding off, you can say 0.19 second. Okay, quite easy. B part, show that the tennis ball passes over the net. Again, whenever these type of question, whether it passes the wall or it passes the net, always make sure how much displacement it will cover in this much amount of time, and then compare the values. So we also did in the previous question, if you had paid attention, if you have watched the complete video. Okay, so what I can do is I will use Sy equals to Uy t plus half Ay into t square. Now Sy I have to find out. So Uy is 64. This is 64 sine. So 64 sine 7 times 0.187 plus half 9.8 times 0.187 square. Now if you solve for this equation, you will get something around 1.66 meter, right? Now if you look here, you are from here, it will be 1 point. So the displacement, or you can say the height from the ground, so you can say the height of the ball above ground is equals to 2.8 minus 1.66. which is 1.1 meter. Okay, and this is greater than the height of net, therefore it passes over the net. I hope it makes some sense. Just go through the calculation. If you have any doubt, just comment below. Now again determine the speed of the tennis ball as it hits the ground. So when it will hit the ground, only the component speed we have to find out. So again v square is equals to ux square plus vy square when it hits the ground. So for that we have to first of all find out the speed. For that I am using v square equals to u square plus 2as. S is given in the question in the downward direction. So vy square will be 64 sine 7 square plus 2 times 9.8 times 2.8 meters. Total it will cover, right? So if you solve for this, you will get y when it hits the vertical component of the velocity when it hits the ground as 115.714. Now if you solve for v, ux is already known to us, which is 64 cos 7, which doesn't change, plus 115. This is the square only, okay, 714. So this v will come out to be 64.42, or you can say 64 meter per second, something near to this. Okay, I hope it is quite clear. Now you can do it. Okay, try question number 7. Pause the video. Okay, now here this is a different type of question. Here the vertical displacement and the horizontal displacement are given, and this is not with respect to time, do not get confused, but this information is given that it is 0.2 second. These dots are 0.2 second apart from one another. Okay, so use the graph to determine the component of the initial velocity of the ball. So in the A first part, what I have to find out is the ux and uy. So ux, I can find out the total distance is 60 and total time, count the number. This is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So total 10, and each dot is of 0.2. So 10 times 0.2, which is 2 seconds. So 60 by 2, which is 30. So the answer for the A part is 30 meter per second. That is my ux. Now for uy, do not use 9.8 guys here. This is not the earth, this is an another x planet. We don't know the gravitational acceleration there. Okay, so we cannot use 9.8 here. I know many of the students have done this mistake, but we are not supposed to use 9.8 in this particular question because it is not with respect to the earth. So in that case, what we can do is we can use the formula in your data booklet. One formula is S equals to U plus V by 2 times T, right? I am using this for vertical component. Now I know that at maximum height the final velocity is 0, so I can say this maximum height is 10 given in the question. Uy I have to find out plus 0 divided by 2, time is 1 second. So you can say this is uy 1 second. So uy is equals to nothing but 20 meter per second. I hope it is quite clear. It was a tricky one. So first we have done now the A. Second part, the angle to the horizontal the ball was launched at. So we know that uy by ux, that is u sine theta divided by u cos theta is tan theta, right? So this will be 20 by 30. This will be, so you get theta as tan inverse of 2 by 3, which will be 34 degree. This will be the answer for the second part. Now for third, we can use acceleration of the free fall of this planet. Now we can use Vy equals to Uy plus At. A is nothing but the G here. So Vy at maximum height. Okay. At maximum height, we know that vertical velocity component is 0. Uy we have already found out 20 plus G times T is 1 second, right? So G comes out to be minus 20 meter per second square. Minus just denote that it is in the negative downward direction. Okay, so do not get confused. Now the B part, make a copy of the graph and draw two arrows to represent the velocity and the acceleration vector at 1 second. Now if you look here at 1 second, it will be here. So it will have only ux and this will be ay. There will be no vertical component because Vy will be 0. So this is done. Okay, now for C, if the acceleration due to gravity is twice as large as, draw the path of the ball on your graph, right? So if the gravitational acceleration is just double, so the maximum height also get half and the range will also get half, because the rest of the things are not changing, right? So if you look here in this same formula, if G is get doubled, okay, if this G is instead of 20 it's become 40, so this tan will become 5. You can do the calculation again, and the range will also, so this will be 30 and this will be 5 somewhat here. So the graph will be somewhat, and the time will also be reduced, so it will be like this. So the graph will look like this. I hope I am clear. So this is the question number 7. This is quite easy. Just read the question, because sometimes they ask for a theoretical answer for the terminal speed. So eventually the terminal speed is the constant speed, okay, at which a projectile as a result of air resistance force increases with the speed. So when an object is moving through the air, as the speed increases, the air resistance increases, and there will be a time when the forces get balanced. At that time the speed remains constant, and that speed is known as the terminal speed. Now with respect to a particular situation, a ball is dropped from rest. The force of air resistance in the ball is proportional to the ball's speed. Explain why the ball reaches a terminal speed. So what are the key words you have to make sure is, initially the net force is just the weight, because it just started the motion. So due to weight it is accelerating in the downward direction. So as the speed increases, so does the resistance force due to air resistance increases, and eventually the resistance force will equal the weight, and from then the projectile will move with zero acceleration, that is with a constant terminal speed. So these are the key words. You can reframe the sentence in your own way, but these keywords must be used. Okay. Now paper 1 MCQ. I have tried to take some past year papers MCQ related to the projectile. Just pause the video and solve. Okay. So the stone is thrown at an angle to the horizontal. If we ignore the air resistance, the horizontal component of the initial velocity of the stone determines the value of. We have solved that u cos theta times t gives us the range only. Okay, so option A is the right answer. Now pause the video and solve question number 2. Yeah, this is the very important concept you have to remember. There is no role of mass in the projectile. So whether you are throwing a ball, whether you are throwing a stone, or whether you are throwing a cannonball, the time it takes or the distance or the horizontal range will remain the same, because there is no role of the mass, because we are not considering the air resistance. So if air resistance is negligible, then there will same time and same distance from horizontal distance. Okay. Now this solve question number 3. Pause the video and solve. Yeah, so this is guys speed versus time. Do not get confused, right? So horizontal component, as I already mentioned, it will remain constant. So C and D gets cancelled. Now, but here this is first decreasing because it is moving upward. It will reach a maximum height where the velocity will be 0, and then it will move down and it will increase. So speed will be like this. So option B will be the right answer. Okay. Pause the video and solve question number 4. Okay. Now here, if you look here, there are two metals X and Y. They are released at the same time from same height. Okay. One just vertically and one horizontally, like this. Air resistance is negligible. Which of the following statement is correct? Now if you look here, this sphere X hits the ground before sphere Y. You have to make sure whenever vertical displacement for both of them are the same, and vertical velocity is also 0 for uy is 0 for X, and uy for Y is also 0. So the vertical component, initial vertical component for both of them are 0, and they have to cover the same displacement. So they will reach the bottom at the same time, irrespective of whether it is dropped or whether it is dropped horizontally. So do not get confused, guys. So the sphere hit the ground at the same time because the horizontal motion does not affect the vertical motion. The time it takes will be the same, but the horizontal displacement will be different, or the distance covered will be different. Displacement is same, that's the why the time will be the same. Now pause the video and solve question number 5. Okay, so here the horizontal range I can say is V into T, and as I mentioned, there is no change in the time. So if V gets doubled, then the new R dash will be VR can be, sorry, this VT can be written as R, so it will be 2R. So option C is the right answer. Okay, quite easy. There is no change in time. So make sure if the horizontal from the same height with the speed 2v, but the vertical component is the same. If the vertical component is the same and the height is the same, then there will be no change in the time whether you throw with horizontal velocity v, 2v or 5v or 100v. It doesn't matter. It will take the same time. Okay. Now pause the video for question number 6 and solve. Okay, so these are the two trajectory of the two projectile launched from the same point. The projectile reach the same maximum height. Which of the same value for both the projectile? Now initial speed cannot be the same. If they are reaching the same height, okay, if they are reaching the same height, then the time of flight will be same for both of them. Okay. Horizontal component of the initial velocity. No, if theta is different, then initial velocity component will be different, and initial speed is different, then C will also be get different. Speed at maximum height. Guys, this is the speed which also cover the vertical as well as horizontal. So I know the horizontal component will always be 0, but vertical component will always be 0, but horizontal component is different. So the speed will be different for both. So why I am saying time of flight is because if you see from here it will go here and here it will go here. So let us say this time is t. So if I use s equals to ut plus half at square for the descent for this from here to here, right? So because I know that if the air resistance is negligible, the total time will be 2 times of t, right? So this is 0 because at this maximum height it is 0. So this h is equals to gt square by 2. So t will be 2h by g under root, right? So the total time will be 2 times of 2h by g. Now if you look here, if the same h is there, because the maximum height is same, g is same, these are all constants, so time of flight will be same for both of them. Okay, so these are some tricky questions, make sure you know this. Okay, now pause the video and solve question number 7. Okay, now an arrow is fired horizontally from height h, let us say this is height h, and travels a distance s, let us say this distance is s and this height is h. Okay, another arrow is fired with the same velocity, okay, same velocity v, and travels a distance 2s. So let us say this is s and this is 2s. Okay, what is the height from which the second arrow has to be fired? I don't know the height, so I don't know from where it should be fired. I have to calculate the height. So let us say I don't know, let us say this is h dash and the another one was this is h, just assuming this. So it was like this. Okay, so if it is 2s, then I have to find out. First of all, using this h, I can find out so s h is equals to, let us say the initial vertical velocity is 0. So it will be 0, the vertical component uy will be 0 in both the cases. So half so horizontal distance is s, so this will be u t, right? This will be ux times t, the time of flight it takes. So t can be written as ux by s. So h is equals to half g ux by h is the height, no sorry, s is the horizontal displacement, so ux by s square. So nu h dash will be half g and this will be 2s equals to ux into t dash. So half g t dash square. So this will be half into g into, now t dash will be 2s upon s upon ux. My mistake, there's some time I also do some calculation error, no worries. So I have made it correct now. So t dash is 2s upon ux, so this will be 2s upon ux whole square. So this, if I open the bracket, half g 4s square upon ux square. So if I use this, I can replace half g this as h, so it will be 4h. So option D is the right answer. Okay, now question number 8, just pause the video and solve. So this is the steel ball, it is at a height h from the ground as of now, and the initial velocity is v in the horizontal direction. So I can say the uy component is 0, ux is v. what is the horizontal distance moved by the ball? So it will move like somewhat like this, right? So from the edge of the table, find the ball when it hits. So we have to find out this in terms of h, g and v. So we know that this distance is nothing but v into t. Now if for t, this is nothing but ux into t. Ux is v, right? So now for t, I can say sy equals to uyt plus half ayt square. So this is 0 because uy is 0. So sy is h, taking downward as positive. This will be half into g into t square. So I can say from here t will be equals to 2h by g under root, right? So using this, it will be v times of under root 2h by g, which is option C is the right answer. So guys, I have tried my level best to give all the different types of questions for the projectile motion. I hope you like this video. So it's my only request is to please share this video with your friends and the classmates so it reaches to the masses. That's the only purpose. And keep learning. If you have any doubt, if you want any tutorial sessions with me, just scan the QR code or see the description below. If you have not watched my previous video, the playlist for the new syllabus IBDP A.1 Kinematics is there in the description. You can check it out. Keep learning. See you in the next video.